Morning and welcome to solving, we'll call them five-step equations. I'm just going to call them long equations. Might actually hit a five or maybe even a six-step equation today. So this is going to be taking all the things that we've been working on for the last 5 weeks and putting it all together in one big problem, okay? And yes, these kinds of problems do exist, and yes, when you get to high school, there will be even longer ones, because that's just the nature of the math, and it's the nature of the planet we live on. There is more complicated stuff out there than what you've seen up to this point. So let's solve, okay? So that's right away, that's our big thing. We're going to be finding the value that makes the statement true, that makes the expression true. We're going to find x, okay? So we're going to have 2 times 3x minus 1 minus, let's go, how about x plus 4 equals, and we're going all out here, so we're going to have, let's go 3x minus 1. That looks like a lot, okay? And I will be honest with you, I don't know the answer, okay? I mean, I made this problem up on the spot, so I don't know the answer, okay? I wasn't thinking about what the answer was while I was making it. I'm not thinking about the answer now. That's the beautiful thing about this whole process, and why it is so important to me that you understand that what I'm looking for is proof of the process. Okay, the answer is not proof of the process. The answer is the byproduct of the process. Proof of the process is me seeing the process. I want to see all the steps. Well, I see multiple parentheses, so I know I've got work to do. So right away, that's always going to be first. That is going to be step one every time. There's ways around it. I will let you know, but we're not looking at those right this minute. What we're looking at is, what do I do? This is already a way around it, because what I should do is 3x minus 1, but I don't know how to do that because I don't know what x is yet. So I'm trying to find a way around it, and that way around it is the distributive property. We'll abbreviate it as distprop. Distributive property, and that is that rainbow effect. So here we go with 2 times 3x, that's 6x. 2 times negative 1 is negative 2. Now we got this minus sign here, which means we want to subtract everything that's in the parentheses. Well, to make that clearer, I'm going to put that value that we've been talking about. If you don't see a value, then that value is always 1. I always like to just be able to say, if you don't see 1, then it is 1. So there's 1, and in fact, that's what the negative sign is. It's actually negative 1. So we're going to distribute that. Negative 1 times x is negative 1x. I'm going to keep the sign, I'm going to keep the coefficient, even though I could drop it normally. We have negative 1 times positive 4. A negative times a positive is a negative. When the signs are different, you get a negative number. Okay. Next step. So we've done our distributive property. We had to do it twice. They only counted as one step, so even though we did it twice, it still only counts as one for purposes of how many steps is this problem. But I like it because it's extra complicated. And the negative sign with no coefficient is even more special. The next is going to be, we're going to combine like terms. And the reason that we want to do this right now is because we have the same variable on the same side of the equal sign, and if we don't deal with it now, it's going to mess us up later. So right away, I want to go 6x minus 1x, or you could see that as just 6x plus and negative 1x. It's simply 5x. We go negative 2 and negative 4. That would be negative 6. Now we have to get the variable on one side of the equal side. And it doesn't matter which side we get it on. If you remember, the previous suggestion was always eliminate the smaller variable or always get rid of the one on the right. In this case, those are both the same thing, so I'm not having to make a decision. But if this was 3 and that was 5, then I would be making that decision. Because of where we're headed, I like to be consistent, and a part of me likes to always get it on the left-hand side a little, just like a hair's breadth more than I like to get rid of the smaller one. But it's really going to be up to you which way you go there, because you're going to get the same answer either way. The question is whether you get your answer as x equals something or something equals x. That's really going to be what the decision is. So I want to get rid of this. I'm going to get rid of it by subtracting it, because that's what will make it go away. See, I can circle it, and this is 3x minus 3x. Over here I've got 5x minus 3x, that's 2x. And what's left over here is just a -1. And then we're down to the sad me part. I'm either going to have subtraction or addition. I have subtraction, so that means I'm going to get rid of it by adding. And then division or multiplication, and most of the time, and not all, I've already seen some of the questions on the homework. There are some where you'll have fractions, which means you'll be multiplying because you'll have division. But we have multiplication here, so we are going to divide. And I'm going to leave it as a fraction. If you really wanted to turn it into a decimal, you can. I honestly don't have a preference. Well, I like this because it's less work. I mean, why do more work when you don't have to? I'm always a fan of do as little as possible that still gets you the right answer. The only time I would deal with this is if I was on a multiple choice test and I was looking at the choices and the choices were already decimals. If I can't leave it like this because they're all like this, then I'm going to take it to that next step and I'm going to do the division and I'm going to get that. But you can see we did distributive property. We combined like terms. We got the variable on one side. We added or subtracted something. We divided or multiplied by something. 5 steps. There's no shortcut through this. I'm not showing this to you so that later on when you get into high school or beyond that you can go, oh wow, this way is so much faster. Now I really appreciate it because I know how to do the long way and now I appreciate the short way. This is the short way. I'm telling you, there's no shortcut through this process. Okay? And the more you know about this process, the easier it becomes to just add a step. Add one more thing here, one more thing there. Okay? But for our purposes, this is the fastest way possible. So you're always, and you're going to be going through this the same every time. So we're going to do one more example here. Really, that's going to take up most of the time here. We're going to do one more example, and I'm going to point something out to us. Okay? So again, let's go 6x minus 2 times 4x minus 3 equals, and then let's go, how about 5x minus 3, let's go plus 2x. How about that? So we got a bunch of things to do. Now, if there were no parentheses, it's not that I skipped this step. Sometimes students think that, oh, I'm skipping a step, okay? I prefer to look at it like this. If you ever work in retail, and most of you will, at some point you may be asked to count out a register, which means figure out how much money is in the register at the end of the night, and it should match up with whatever you've sold throughout the day. When you go to count the register, the first thing you do is you count all the pennies. Then you count all the nickels, then you count all the dimes, and you count all the quarters, and so on. And that's essentially what combining like terms is all about. But the big reason I bring this up is if you go to your register and you're going to go count it out, and the first thing you notice is that the little bin where all the pennies would be is completely empty. It's not that you skip the step of counting the pennies, it's that you acknowledge that the number of pennies is 0. That you are at a specific step, and the specific step says how many are there, and your answer is there are 0. Well, for us, if this were not here, it is not that I would just say I'm skipping the distributive property. It's that I say I get to the distributive property and there's nothing for me to do at that step. I'm acknowledging the step and doing what I need to. In this case, there is. So I again have that negative sign in front. So the 6x is the same. We have -2 times 4x is -8x. Again, I draw that arrow and I circle the sign with the number. Okay, these are two good strategies for guaranteeing correct answers. Okay, -2 times -3 is +6. Again, equals 5x minus 3 plus 2x. So now we're going to combine like terms because I've got two sets of like terms. The like terms are on the opposite, on either side of the equal sign. In fact, sometimes I see students do this. I've seen that as a strategy to really drive home that I'm doing something to the left-hand side. Right now, I'm just neatening it up. 6x minus 8x is -2x. Now I'm onto the right-hand side and I'm just neatening it up. 5x plus 2x is 7x. Okay? I did the combine like terms. I did it twice. Now I want to get the variables on one side. Now I have that problem again. Now this time I actually have to make a decision. The smaller would be the -2, or I can get rid of the one on the right. Okay? There's no wrong way to do this. It's a preference. Okay? Each has its values. Getting them all on the left-hand side will help you with what we're going to be doing next, which is solving inequalities. But getting rid of the smaller one always guarantees you a positive coefficient, which makes life easier in the long run. So, which one do you want to do? Doesn't matter to me. Okay? I want to deal with positive coefficients. Well, no, I'm looking ahead. I'm going to make my life harder. I'm going to subtract the 7x from both sides because I want to have it on the left-hand side because I know what we're going to be doing next. -2 and -7 make -9x plus 6 equals, and what's left over here is the -3 because again, this is 0. 7x minus 7x is 0. Now we're into the sad me. I've got some additions, so I'm going to subtract. -9x equals -9. Divide both sides by the number next to the variable. And amazingly, the answer was 1. And I promise you, I had no idea what the answer was when I wrote it down. I literally was just throwing numbers down like for fun. Okay? And that's the beautiful thing. Again, I've said this before, but I want to repeat it one more time. Okay? When you're solving problems like this, don't, it sounds so weird to say, don't think, react. What do I see? I see a parentheses. What does that tell me that I need to do? It tells me I need to do something called the distributive property, which is I need to multiply the number that is outside the parentheses times everything that is inside the parentheses. And you know what? You can have parentheses that are longer than just 2. It could be 10. There's nothing restricting how long it can be. And I promise when you get into high school, you'll be doing more complicated distributive properties. But if you master this one, when you get to those more complicated ones, it's like learning how to walk and learning how to run. It's just that next level of difficulty. It's not super hard. Again, next up, combine like terms. I did that twice, once on each side, because I had to. Okay, getting the variable on one side, and again, I could have added the 2x. This would have made this a +9, and it would have ended up the same, except that it would have been 1 equals x, as opposed to x equals 1. What is the difference? There isn't one. Is it 1 equals x or x equals 1? Those two things mean the same thing. All right. This is a lot, okay? And again, what did we do? We did distributive properties, so we did one step. We combined like terms, we did a second step. We added some, we subtracted some. We got the variable on one side, that was a third step. We subtracted from both sides, and then we divided both sides. So we did 5 steps. This is really the top of the food chain when it comes to the complexity that we're going to deal with in this class. Now, again, next thing up is to go 6 steps, okay? And we could easily go a 6th step by, instead of this being a 9, what if it were a 2/3? Then we would have to multiply and divide. So we'd have to do 2 things at the very end. What if, what if this was an exponent? What if that was x squared? Then when we got all the way to the end, we'd have to take the square root. We'd have one more step to do. That would be our 6th, that would be that E that I keep leaving off here at the bottom. That would be that one more step that we have to do to get the answer, and that would be, so we would have a 6th step, and a 7th, and an 8th, and you'll just keep going until you get into the point where you actually can decide, I don't want to take any more math, or I need even more math because of the science that I'm particularly pursuing, or who knows what, okay? This is about as complex as you're ever going to see in your everyday life? I always love that question. Students ask me, when am I going to use this in my everyday life? Well, let me tell you, this is complicated. Don't get me wrong. I'm not saying it's easy, but I am saying that when you start to have to do your own taxes, you have to be able to do this level of math to be accurate. And I know people are thinking, oh, I'll just hire somebody to do my taxes. First of all, you have to pay them. Second of all, they don't know everything about you that you do. And sometimes they don't know what they need to know about you because you don't know to tell them. And if you don't know it and they don't know it, then they don't apply it. And it's almost like, what if I just took this 2x off the board and did the whole math problem? I wouldn't quite get the right answer, and I might end up paying too much taxes or not getting as big a refund as I'm entitled to. I promise, this is the kind of math. I always refer to this as the math of what if. What if I got paid more? What if I made a bigger input into my 401k? What if I got a raise? What if I got a better loan on my car? What if I paid a higher interest rate? What if I paid a lower interest rate? What if, what if, what if, what if? That X is the what. What if we did all of this? This is my answer. What if this was not there? How would things have changed? Okay, that's the math that we're looking at here, the math of what if. Okay, this is long. I know it's time consuming. I know how much homework I'm going to be giving you. I need you to show your work on every step. Okay, whether you do it on a separate sheet of paper, probably can't even do it on the sheet anymore because it's just getting too long to do on where you're not writing on a separate sheet of paper. So again, you're showing your work on every step, okay, because that's what I'm looking for. If you told me looking at this problem the answer was 1, I don't actually care or even believe you. I mean, maybe you got lucky and you just tried 1 out and it worked. Okay, that'd be fine if this was a multiple choice test, but it's not. This is where you're demonstrating the skill. Okay, that's what we're looking for. That's what I'm looking for. That's what you need to demonstrate. Okay, so again, I will see you in office hours or in class.